Hi everyone, very good morning to one and all. It's been a long time that I have been taking the videos in my YouTube channel. Because of some works, I am not able to do the videos. Now, in this class, I will start a new topic in our subject, which is switching theory and logic design. So, the concept name is Boolean algebra. So, let me write the name of that concept, which is Boolean algebra. So this Boolean algebra is simply one of the method which is used to minimize the switching function. We will see what is the purpose of minimizing the switching function later. So the purpose of Boolean algebra mainly is to minimize the switching function. And this Boolean algebra was introduced by the scientist named George Boole. This is the name of the scientist who has introduced this Boolean algebra in the year 1847. Now, what is different in this Boolean algebra? What difference it has compared to elementary algebra? So let me draw a small tabular column which gives us the difference between elementary algebra, which we have studied since our childhood, and Boolean algebra, which we are studying right now. There is a small difference between this elementary algebra and Boolean algebra. In elementary algebra, we perform many mathematical operations like addition, subtraction, multiplication, and division. These are the various mathematical operations that we will perform in elementary algebra. Whereas in Boolean algebra, we perform various logical operations like AND operation, and logical OR operation, and complement operation or NOT operation. We also call it as NOT operation. This is the basic difference. And also the variables in elementary algebra can be any value, can have any values from 0 to infinite. You can have 1, 2, 3, 100 like that. Whereas in Boolean algebra, the variables can have only two values, either 0 or 1. We call 0 as false here and we call 1 as true here. This is the basic difference between elementary algebra and Boolean algebra. Now, before going to understand what are the various postulates of Boolean algebra, it is better to know what are its logical operations. Means when two variables are joined with AND operator, what is its output? Or when two variables are joined with OR operator, what is its output? That we need to understand before going to the postulates of Boolean algebra. So let me draw a table which gives us the output for logical AND operation with various combinations of input. For example, if I assume A as one variable and B as another variable, the logical AND operation between A and B is represented by either A dot B. This is the notation which is used to represent the logical AND operation, or you can simply write it as AB. So the logical AND operation is represented like A and B or A dot B or AB. Now let me show you tabular column which gives us the output with logical AND operation for various combinations of variables. For example, if I consider two variables A and B, and let me show you what is the logical AND value when I join these two with a dot. Now, what are the possible combinations with the two variables here? There are basically four possible combinations with the two variables. The four combinations are A can be 0, B can be 0, A is 0, B is 1, A is 1, B is 0, A is 1, B is 1. These are the four possible combinations of A and B variables. For all these four possible combinations, let me show what is logical AND gives us. When both are low, logical AND output will be also low. And when one of the input is low, logical output again is low. Here B is low, that's why logical AND output is low. When both are high, 1 and 1, the logical AND operation will gives you high output. So this simple tabular column gives us logical AND output for various combinations of input. This is the first basic operation, logical operation, which is performed in Boolean algebra. Let me show you second basic logic operations, which is logic OR. Okay. So the logic OR operation between the two variables, capital A and capital B, is represented by A plus B. This is the symbol or this is the notation which is used to represent the logical OR operation between two variables. If you have more than two variables, you can write A plus B plus C like that. Now, let me draw one more tabular column which gives us logical OR output when we perform this logical OR operation between the two variables. Okay. So this the third column gives us logical OR output and the first two columns gives us the values of the variables. If you have only one variable, there are only two possibilities, either 0 or 1, as I have shown here. But as we have two variables, there are four possibilities. A and B both are 0. A is 0, B is 1. A is 1, B is 0. And A is 1, B is 1. These are the four possibilities. Now, for each and every possibility, what is the logic OR output? Now we will see. When both are low, the logic OR output will also be low. When any one of the input is high, the logic OR operation will gives you high output. So for the next three combinations, I will get the logic OR operation as high output. This is about the logical OR operation. And let me show you third basic operation, which is complement operation. This is the complement operation. Complement is simply just negating the value. If the value of the variable is 0, by taking the complement, you can get it as 1. If the value of variable is 1, by taking the complement, you will get the value as 0. This is the simple thing. So that if I can draw a table like this with one variable, I can have two possibilities, 0 and 1. Now, a complement means the complement of the variable a is represented either by a bar or a dash. These two are the notations, or any one of these two notations is used to represent the complement operation. Now, when a is 0, a complement will be 1. When a is 1, a complement will be 0. This simple table gives us how can you do the complement operation for a particular variable. So these are the three basic operations that we can perform in Boolean algebra. In the next class, we will understand each and every postulate in detail. Thank you very much.